And welcome everybody to the Daily Space Weather. Today we're talking about the Sun, a Precession teaser, an old faithful galactic nucleus, and the jet stream. First thing we're going to do is we're going to look at the star of the show here on the Smash News Network, the star of your solar system. It's the local yellow dwarf. Sunspot 2804 has degraded a bit. We see an intermediate umbra evaporate completely. Trailing umbra shrunk a little bit, and the leading umbra shrunk a little bit as well. No other sunspots on the solar disk right now. Here's the colorized magnetogram. The possibility for significant solar flares still remains, and the possibility for additional coronal mass ejections still remains. Let's talk about our mission. You can read more about our mission at smashomash.com/forum/mission. Number one is to assist, study, and report on the ongoing formation of a unified theory of physics. Now, space is a great laboratory in which to study things like physics, as we see things going on in space that we couldn't possibly replicate on Earth. So whether you've got CERN or not, or whatever you're doing in your laboratory, it's not quite the same as, for example, an active galactic nucleus. And that's part of the reason why we study cosmology. The implications for human technology and so on are, shall we say, vast. So here's a quick fade here on HelioViewer. The fade to 304 and 171 angstroms. I like the way the differences in the ionized helium here and the ionized iron at 171 angstroms show. Here's an animation in just 171 angstroms. Again, there is quite a bit of plasma filamentary material in between the Sun and the Earth right now, suspended out there in the corona. Don't be surprised to see us make more videos about additional coronal mass ejections if one happens. I would also note this filamentary region down here. Quite a lot of filaments hanging out there for a few days at the southwestern limb. And we call that the west, folks, because that is where solar activity sets. The Sun rotates faster than the Earth orbits it. So from the Earth's perspective, space weather rises on your screen left and sets on your screen right. We did see a B-class flare happen right as I was getting out of bed once again this morning. And thanks once again for the signal, El Sol. Here's that animation at 304 angstroms. We've got a coronal hole wind stream on the way. That should be here in 2 to 3 days. And it's coming from that large empty space there, this coronal hole right down here. It's South Pole oriented. And there's another one rotating in here. We see some North Pole magnetism there. So the solar polar field reversal is starting to happen right now. We see some minor changes in the Sun's B field. We'll show you that later in the video. As during a solar cycle, the Sun's solar polar fields reverse their polarity. And it's evidenced by the migration of coronal holes from the poles across the equator and to the opposite poles. So we see this near equatorial region here, and there is North Pole polarity in there. Again, we'll show you that a little later. And here's a close-up of the coronal hole from which we will be receiving some geo-effective solar protons and other material in a couple of days. Expecting at least geomagnetic unrest conditions from that. And we'll show you some more close-up images of the Sun, namely sunspot 2804 toward the end of the video. First, here's a chart of what's going on in the solar system. At the Smash News Network, we prefer to provide facts. So here are some more. Here's where planets are located. Happy full moon. There's where things will be in 1 week. A gibbous waning Here's a star chart. If you're up before dawn, you may see Saturn rising before the sun, as well as Mercury. As the moon sets, the radio flux is still at 80 solar flux units, out of solar minimum conditions. A little bit of stagnation there. You can see this line flatlining here at the end of the graph, that upper black line. That's the 10.7 centimeter radio flux, a measurement of the solar coronal radio emissions. That's a 1-year chart to put that in context. And here's a multi-year chart, about an 11-year chart. And this would actually be a little bit higher than this someplace around here. And the Space Weather Enthusiast dashboard is what we're looking at here. And you can see how proportional the radio flux is to sunspot number. Probably the second most important small-scale piece of data to look at, the 10.7 centimeter radio flux. Let's see what volcanoes have been erupting. Last night we covered some mass erupting from the solar corona. And yes, we did clickbait a little bit because, well, I have a pass. I have a clickbaiting pass. Here's what volcanoes are erupting. Indeed, Mount Abiko is exploding, producing a 14,000-foot ash plume. Suwano Seijima. Unknown volcanic ash plume. Please do not attempt to pole vault that caldera. Dacono is exploding as well, flight level 070. It's a 7,000-foot ash plume. Popocatépetl exploding down in Mexico, 20,000-foot ash plume. Pacaya and Fuego in Guatemala are on the list. Pacaya is exploding. It's producing a 13,000-foot plume of volcanic ash. Fuego, no volcanic ash observed. Please do not attempt a back handspring over that caldera. Sangay in Ecuador, volcanic ash not observed. Please do not attempt to do a Fosbury flop over that caldera. There could be a volcanic ash plume there. It's probably just not visible in satellite imagery. Reventador, also in Ecuador, is exploding. 14,000-foot ash plume above that. And Sabancaya intermittent emissions are a reminder not to build a campsite on the lower slopes of the Peruvian volcano Sabancaya. Mount Etna now off the list, at least so far today on February 27th. No major quakes happened, although we did see one in Iceland and a few mid-5 level quakes, such as this 5.8, which I think was the largest of the past 24 hours. Southwest of Australia there in the southern Indian Ocean. Not far from the South Geomagnetic Pole, I might add. So we see like 4 shocks there happening in Iceland. One of the largest of the past 24 was a deep quake near Fiji. We'll get to it in a minute. Here's a 4.2 magnitude quake at over 100 kilometers depth at Afghanistan, followed by a 107 kilometer deep quake at Chile. It's a 4.4 magnitude. I think this is the second largest of the past 24 in the deep quake capital of the world, Oceania, a 5.6 magnitude at over 550 kilometers depth. And here's this quake at Iceland, actually very close to Reykjavik. If you felt that quake, if you watch the daily space weather videos, leave us a comment. From Iceland, one of my bucket list vacation spots. Another deep quake in western South America, as well as on one of the volcanic islands at Japan. Those both in the 4 magnitude range and happening only 1 minute apart here. So a 4.3 in western South America, followed by a 4.8 at Japan at similar depths and pretty similar magnitudes. If you haven't checked out our own website, we are AltTech, smAsho.com. You'll find our social media links there. Get involved, send us a message. Check out our merch shops. Today I'm wearing one of the merch products. You can find that at the smAsho merch link. Go check that out if you like. Support the channel that way. And today's featured product is the Google Bias shirt. Here it is. The print quality is incredibly high. Don't use it as a verb unless you're using the verb Google to mean to obtain biased internet search results. Let me use it in a sentence. I Googled it and now I know less about it. Also, you can find links to our Teespring stores there. smAshomash.com. Lots of links. Lots more content to be put up. And you can also find some smAshomash.org presents the sun videos. smAshomash.org, the URL, will redirect you to this page. This smAsho stream was brought to you from twitch.tv/smAshomash. It's such a great live streaming platform that we use it on the regs. And we're back, thanks to our Twitch followers. If you're viewing on YouTube, please don't forget to press like and subscribe, press the notification bell, and press that share button to share with your friends on social media. We've barely begun creating content, so get it on the ground level. Leave us a comment, tell your friends, your foes, your science noobs and science pros. We're also on BitChute, bitchute.com/smAshomash. And if you're on the channel because you saw one of our business cards, please leave us a comment. As we've changed our marketing and will continue to change our marketing, in the realm of marketing, if your marketing is remaining the same, you're failing. Let's do a cosmology segment. And this one is going to include a teaser about precession. Yes, we're about to create a pretty in-depth video here about precession and an explanation of a mystery in the realm of cosmology. So precession is the axial wobble of a rotating object, and in space, everything precesses. Really, every rotating body precesses, period. And that axial wobble does all kinds of interesting things, like, for example, changes the Earth's celestial pole star. The Earth has several different celestial pole stars throughout its precessional wobble cycle, which is about 24,000 years. And, for example, Deneb, Aldebaran, and Polaris are examples of celestial pole stars. And with respect to the Earth's precessional wobble, that green rod you see sticking out of the top of that virtual top there would be the Earth's celestial pole, and the star at which that points would be the Earth's celestial pole star. All the stars in the sky would rotate around that star from your perspective, and right now it's Polaris. In about 12,000 years, it'll be Deneb. Enough about that, and we're not going to do any random objects today. I accidentally clicked on this object, a low-mass X-ray binary / black hole. I'll refer to it as a massive radio source, V404 Cygni. So this one is interesting in that it had one massive outburst back in 2015. Since then, not so much. Here's some imagery of it. This is the 16-year chart. Here's the 2-day chart, and here's the 30-day chart of the X-ray outputs from V404 Cygni. And we'll show you this real quick on a couple different wavelengths on Aladdin Light. You can link directly to all that stuff from the Neil Gorell Swift Bat X-ray Observatory. And there it is in infrared. Here it is in optical light from Pan-STARRS. Pretty good resolution there. You can actually see both components of the low mass binary, it looks like. And last but not least, we'll show you on the Chandra. There it is in the Chandra X-ray telescope. Possibility of some jets coming out of that, perhaps out of one of the components of that X-ray binary. Again, that's V404 Cygni, which happens to be entry number 936 on the Neil Gorell Swift Bat X-ray Observatory, the low-mass X-ray binary massive radio source referred to by some as a black hole. Follow your favorite transients there in the X-ray spectrum. Let's talk about this Old Faithful galaxy. Here's an image of it. And what is going on with that? That galaxy is super interesting in that it exhibits a multi-wavelength outburst every 114 days. How does it do that? Well, there are 3 possible scenarios as to how it does that. And the possible scenarios are interactions between 2 disks. In other words, there could be 2, quote, supermassive black holes and, quote, rotating around the core. There could be a star passing on an inclined orbit through the disk of ionized gas close to the galactic core, or a tidal disruption event, which I think is actually the least likely because of the similarity to all of these bursts. So you can see how similar each burst is. If it was a tidal disruption event, you would expect to see maybe a decreasing amount of brightness for each burst or something like that, as a star being, quote, tidally disrupted and, quote, loses mass. But in any case, if you want to read the paper about this one, it's located at SciTech Daily. Headline: NASA investigates old faithful galaxy that erupts every 114 days. And another interesting fact about this is we'll be able to see additional information coming out about this one in April and August of this year. So I'll just let the article scroll here. You can read it if you like. Feel free to pause the video at any time. The beauty of video on demand is that we'll be here when you press unpause. So this was discovered by actually an automated supernova project called the Assassin, the Automated Supernova Survey. And again, that article is on SciTech Daily. That's today's cosmology segment. Let's get back to more local data. And here's the X-ray flare that occurred while I was waking up this morning. Here's one that happened as I was getting out of bed yesterday morning. So once again, if you've got messages to leave directly for the sun, just leave them in our comments. Perhaps we'll read them in tomorrow's daily space weather video. We don't see any proton strikes here on the GOES 16. Keep in mind the GOES 16 makes its measurements in the ionosphere layer. So no proton strikes, but I think we saw a small coronal mass ejection strike last night. So you see right here, we see the solar wind temperature drop, and we see the solar wind speed and density coming up here at the same time. Solar wind density made it all the way up to over 20 protons per cubic centimeter, and now that's subsiding. It looks a lot like a minor coronal mass ejection strike. And we can't always forecast these, folks, as the material ejected from the sun often takes weird paths through the solar system, and it's essentially invisible once it leaves the corona. So we have to do all of the calculations as the material leaves the corona and then make a lot of guesses. So part of the reason that we make the videos is to continue to refine the techniques by which to make these calculations. And we've got all kinds of ideas as to how to do that. Anyway, we see various shifts in the phi angle here. You see the phi angle. That would be the angle of the incoming particles. You can see the BT-BZ, which is the upper plane, a measurement of the actual magnetism. And the phi angle kind of all over the place for the past 12 hours. Current conditions are subsiding here. Current solar wind density 5.9 protons per cubic centimeter. Current solar wind velocity 396 kilometers per second. Back to basically a weak solar wind condition. The KP index, a measurement of global geomagnetism, now at 2. Here's 4 hours of data about the magnetosphere based on the space weather modeling framework. It's the Magnetohydrodynamic pressure measured in nanopascals. And we show it daily. This is part of a daily archiving service. We put 4 hours of data in most all of our daily space weather videos. And you can see the pressure dropping down, especially on the bow shock region to your screen left. Here are ground magnetic perturbations, and since we're living through a geomagnetic excursion, where the South Pole has left the Antarctic continent and is someplace down here south of Australia, and we've got two North Poles, one over Siberia and one over Canada. We show this daily as well. And the net North Pole is someplace around here. Anyway, there's 4 hours of delta B, geospace delta B, which is changes in the Earth's B field. More about B fields coming up. First, the GOES magnetometer. And we did indeed see the scale expand here to fit this small little spike where the reading went all the way up to 154. nanotesla. That's a 3-day chart as measured by the GOES-16, again in the ionosphere. So here is the top view ecliptic plane field plot. We're looking at the National Sunspot Observatory Gong 2 data. The magnetic data derived from 51 ground-based magnetometers here on Earth, as well as one at Lagrange point 5 on stereo A and one at Lagrange point 4 on stereo B. Earth still in the South Pole current sheet shown here in red. And don't be surprised if this extends, if we stay in the South Pole current sheet until tomorrow. Although we may switch into the North Pole current sheet, keep in mind the magnetic environment can suddenly change, so no forecast there. This data, 1 hour and 15 minutes old. So here's a view of the sun's B field shown in blue, and you can actually see some changes in the sun's B field, especially around this area. We see a migrating coronal hole. It looks like it's from the North Pole. We'll show you that in the next frame. This also shows you the solar magnetogram and the poloidal fields. And you can see a little bit of green all the way down here toward the equator, an indication that the solar cycle is commencing. This is the line of sight coronal hole plot, and you can see right in this area, you'll see some green coronal holes there. Those are North Pole oriented, quite close to the equator. And we'll be keeping a close eye on that. And when I say eye on, well, the pun is intentional. And let me just check the life of the stream, and everything looks just fine. Again, we are streaming to Twitch. It's twitch.tv/smAsho. They've got a great mobile app. Here's a magnetic field plot of the sun's atmosphere, the solar corona, a chaotic place indeed. Enough said about that. Here's a diagram of the atmosphere showing you the different layers as well as the penetration of electromagnetic radiation. For example, visible and infrared light make it all the way to the surface, but extreme UV is actually adsorbed. That's with a D, adsorbed, by the time it reaches the thermosphere. The red F on the right is where the GOES-16 makes its measurements. Here's another diagram showing you the radiation belts surrounding the Earth, the Van Allen belts, as well as altitudes in miles of various spacecraft. Again, feel free to pause the video. We don't see any charging hazards as we move into the realm of electrons. Here's the 3-day chart of electron flux, and we did make it well into electron warning territory here once again yesterday. That's about 15,000 pulse flux units. Well over warning levels. And the forecast was way off by NOAA. I did not make a forecast yesterday. Here's the 1-year chart of the electron flux. And again, that's all measured by the GOES-16 at the ionosphere layer. It's the inner Van Allen belt. And here is the forecast model. And you can see how far off the forecast was. The yellow diamond is the observation. The blue square is the forecast. And the NOAA forecast here for electron flux is for a fairly level, slightly lower electron flux. And I'm not going to go out on a limb and forecast electron flux this time either. Here's a total electron content model. This is a visualization from about 12,500 miles of altitude down to your GPS handset. And we see some quite high density regions here. This is essentially a count of how many electrons are in that column of air. And we see large GPS errors there, especially around the Central Pacific off the west coast of South America. And the equatorial region at noon is where you'll see the most GPS errors. Here's a visualization of the ionosphere. We show this daily as well. Nothing too weird going on in the ionosphere right now. Here's the latest image. That one coming in at 10:45 Universal Time. I wanted to note the surface winds here. So we're looking at the eastern world here, the surface winds as reported by nullschool.net. And we've got 2 strong cyclonic systems here. So you see this clockwise rotation in the southern Indian Ocean. We're seeing winds of at least 59 miles per hour there. Pretty powerful system there. And also one off the coast of Kamchatka, the south tip of Kamchatka, a powerful counterclockwise rotating low pressure there. And for you meteorologist noobs, low pressure systems rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Let's look at the jet streams. In the form of the 250 hectopascal winds, it's a very specific portion of pressure, 250 hectopascals. There are the jet streams, and we see strong jet streams here over the western Pacific, Indonesia, Papua New Guinea, and so on, blowing straight up backwards, east to west. Normally the jet stream blows west to east. And the western world's jet streams are extremely chaotic, especially the southern hemisphere. Look at the extreme trans-equatorial meridional jet stream flow here, classic meridional jet stream flow, extremely chaotic. Big bends, jet stream blowing south to north here. Expect warm temperatures in Iceland, actually, as a result of that southern air. And the jet stream is probably the best single piece of data you could look at if you wanted to make global scale weather forecasts. The U.S. dominated by high pressure, it looks like, as we have a strong band of jet stream over most of the country. Here we are at lightningmaps.org, and we're still seeing a lull in lightning here over the past solid week. Very low levels of lightning. It's a real-time lightning map. And let me just hit refresh here to make sure that it's actually showing us the data. We see 0 lightning strikes happening as we make the video. A lull in lightning. Next, looking at pressure maps. This is windy.com. And we see one fairly weak low pressure system there just north of the Texas stovepipe. Let's advance this into tomorrow on the GFS forecast. That's a GFS forecast for pressure at 12 noon Eastern Time tomorrow. Low pressure dominating the entire south polar region. As you can see here, low pressure all around the south geomagnetic pole, the south geographic pole. Next, looking at clouds. Here are clouds over the U.S., and here's water vapor. Clouds, water vapor. Doesn't look like there'll be too much precipitation, although we got some additional snow. I was joking around with Smash staff about it last night, and it wasn't that funny when I looked out and saw the driveway coated once again here in Lehigh Valley, Pennsylvania. If you're wondering where that is, thanks for tuning in. You're probably a new viewer. We're located about where I put that purple dot, right about there. And here's a U.S. Doppler Radar Map. No real major systems here, although quite a bit of snow showers in the northwest. Some heavy snow in places like southern New York, Connecticut, Massachusetts. And apparently no lightning associated with those storms over places like Kentucky and West Virginia. And hey, Smash team, thanks for tuning in. Don't forget to stay tuned for bonus segments. Don't forget to press like and subscribe. Otherwise, I could start on fire, and nobody wants that, as it's getting hot in here. And thanks for leaving a comment, Amp Mods. Yo to you, Amp Mods. So here come bonus segments. We're going to show you the colorized magnetogram, but first, we're going to thank our patrons, the true source of funding for the content, as we make just this side of nothing on YouTube. So please, again, don't forget to share the videos with your friends and your foes and your science noobs and your science pros before we suddenly vanish and stop making the videos free and publicly visible. Our patrons are responsible for that. Thanks again, patrons. Here come bonus segments. It's the colorized magnetogram. Here's a close-up of sunspot 2804. Looks like it's further weakening to me. The trailing umbra could even be gone by now. But nope, it's still a beta-class sunspot. The possibility for significant solar flares still remains, despite it being so close to the northwestern limb. Here are some animated close-ups of that to close things out. First, 193 angstroms. And we see some interaction there between the leading and trailing umbral groups. Here's 131 angstroms, another one of the ionized iron emission states. Great view of that. Little interaction happening there. I think that is probably the source of the B-class solar flare that I woke up to today. Here's 94 angstroms, another ionized iron state. And indeed, that B-class flare must have come out of that area. Fantastic view there. In the beautiful emerald green color spectrum of 94 angstroms. And here's 171 angstroms, the close-up sunspot 2804. It's about time to close this thing out. Thanks again for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do drink, don't drive. Seriously, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance, and may that solar wind be at your back.